So here's my first question. What strategies are being implemented in modernization and enhancing efficiency in energy transition landscape? Let's have Pankajji's views first, sir.
Talk about my domain of work. In energy efficiency space, there are work going on from policy side to the end user side to the contracting side. From the policy side, Government of India is now made mandatory ECBC, which is an energy efficiency building code that helps in you know uh, uh, making energy efficiency a kind of not voluntary, it is a mandatory that any buildings which is especially government buildings and large buildings, they have to follow the ECBC code. So this is happening. There are various norms which has come up from other side, from private sector side. There are sustainable initiatives. All corporates, big corporates have their own SDG goals. So there are green rating system from US Green Building Council, India Green Building Council, and GRIA, which is the Ministry of New and Renewable Energy. So these bodies are crediting or accrediting with platinum rated, silver rated, gold rated. So this gives a kind of a emphasis for achieving SDG goal to these private sector. From end user perspective, it is the cost. If it is the bottom line, if energy efficiency is there, then spend less power bill. So it is a direct impact on their pocket. So they are concerned for their pocket. And from a contracting side, if the companies have to achieve the contracts, they have to meet the criteria of performance. They have to be they have to purchase equipment which meets the coefficient of performance criteria specified. So I think it is happening on all fronts, and which is a good sign in our country that things are moving from voluntary to mandatory, which is a big implication.
Thank you, Pankajji, for answering that. Subramaniamji, would you like to add into what sir has just answered?
I can maybe again speak from the industry that my company represents, more on the automotive side and on the power generation. So when we look at this entire energy transition, for example, as we are moving from diesel uh, vehicles, commercial vehicles, into the future, say the EVs or the hydrogens. So we have in Cummins, we started off this concept called as the hydrogen ICE, which is basically the internal combustion engine, which is running on diesel typically, but it is made to run on hydrogen. So you don't have to do too many modifications onto your basic engine. With minimal modifications, it becomes suitable to be running on hydrogen. Because the other extreme or the other option is for using hydrogen is you typically use the hydrogen fuel cells. So these are the only two options that are available for the medium and heavy commercial vehicles if they have to run on hydrogen. So the hydrogen fuel cell requires an entirely different architecture of the vehicle, which then makes the entire OEM to design the whole thing. So the hydrogen ICE was designed as a bridge technology so that it can be used as the hydrogen infrastructure progresses. The adoption of hydrogen ICE could happen, and then slowly it could translate or transmigrate into the hydrogen fuel cell as and when that becomes a viable option. So this is one indigenous or one ingenious technology that we have adopted for energy transition.
Thank you for answering that. Saloni, we would like to have your inputs.
I agree with what the speakers have said. Maybe the narrative I would like to share is both from the supply and demand side in terms of efficiency of the grid. So from the supply side, I think what is happening and still needs to happen is better forecasting and scheduling by the discoms on the supply side, better resource advocacy studies, and in fact now the Central Electricity Authority has come up with a mandate for all states to come up with resource advocacy plans to know, okay, what is the kind of peak power management needed at the state level, what is the generation and supply gap meeting strategies at the state level. So all of this at the supply side has happened in the past and is happening, but will require much more effort, because at present I think it's only 2 states who have come up with draft resource advocacy plans and the others still have to. On the demand side, what I would like to quickly add is on a few interventions that I feel would be very important, be it demand side management, where a number of initiatives have already been taken by the states. Rajasthan took a lot of ER events that happened, and then there are strategies of time of day and time of use tariffs that can be taken to have better demand side efficiency in terms of motivating and informing the customers about the benefit of utilizing or using the powers in non-peak hours, and that is the kind of economic benefit that the discoms also get out of it. And especially, I think time of day tariffs for CNI consumers, which is also a regulation that has been talked about and it is in progress. So I think very quickly these two perspectives I would like to add.
Thank you so much, Saloni. Akhilji, please share your thoughts.
The strategy here is, of course, to look at the techno-economic feasibility of the energy transition, whether it is in the generation side. Of course, that's very easy, the putting the solar plant or wind. But very important is also how do you evacuate the power through the grid and having the efficiency, also keeping the grid stable. Because as I said, intermittency and losing the inertia, that's the negative aspect of it, but it has to be handled. And so what we do, we also do that with government and policy making bodies that jointly we do this techno-economic analysis, application of technology. I gave example of HVDC link. So whether it is undersea or in the Himalayas, in the mountains, so whether that technology is feasible from technical point of view, which we have seen that in undersea and normal environment is there, but high altitude you are doing it. But at the same time, cost of the technology, it will be obviously expensive, but how the ROI is going to be. So it's a long-term ROI, not just financial ROI, but also the environmental ROI. So strategic ROI, I think this is something looked at. And as a country, we are doing it, but also we are sort of cooperating. We are considering a super grid in the region, right from Oman in the Gulf to India to Andaman to Singapore, Indonesia, and then of course Singapore, Indonesia, and Australia. So there are a lot of different interconnections being discussed in different forum, how to exchange the renewable energy so that we have a larger window period for using the renewable energy, solar or wind, and have the exchange of power among the countries. I think that's the bigger strategy what we are looking at.
Thank you, Akhilji, for answering that. Rajeshji, can we have your inputs?
And my views based on my experience, and I will be talking on behalf of transmission and distribution sector. Yes, with the advent of latest technology, we have to adopt that technology, but all these technologies have some challenges along with the benefits we are getting, like cyber security, skill and knowledge. And another issue is infrastructure investment. For every new technology adoption, you need approval. You must have that policies and rules. Support of government is required. You have to train your person to adopt the new technologies that is coming. You have to change the mindset. You have to train people, and at the same time, you need support, technical support, financial support. Without support of governments and change the regulations, it is not possible to adopt the technologies available. And it is good thing is that many utilities have already taken the step towards modernization of their system, and they have their own story to tell. Still, many works to be done, many targets to be achieved, and it will be achieved with the support of governments and the infrastructures we develop.
Thank you, Rajeshji, for sharing your inputs. Moving ahead, my next question. How are we going to address the challenges to achieve sustainable energy transition? Akhilji, can we start with you? Please share your inputs.
So good question in terms of, so what we say is, I mean, we have to, it's like, digging a tunnel, you do from one side, you take a lot of time. You have to do it from both the sides and meet somewhere. So while the generation, on the generation side, we have a lot of renewable energy, solar, wind, and all they are coming up. On the consumption side, also we have to look at, which is being looked at in terms of electrification of the mobility, the electric vehicles, the railways, lot of electrification in the buildings, industrialization, industries, and especially the using the green hydrogen in the process industry, steel making, oil and gas, chemical. That is also happening, and in the process we also use sustainable assets. I mean, you talk about transformer or switch gear, transmission line, they also have to be sustainable. So while they carry the sustainable energy, they also themselves have to be sustainable in terms of material use. I will give one example of so in the high voltage, the switch gear, the circuit breaker. So the industry uses technology like SF6, sulfur hexafluoride gas, which is a very, very heavy gas in terms of carbon footprint. So now, for example, as Hitachi Energy, we have come up with a replacement of this SF6. We call it iconic gas, iconic switchgear. So that reduces the carbon footprint and CO2 emission by almost 90 to 95%. Similarly, in the transformer, what type of material you use? I mean, steel, for example, transformer uses a huge amount of steel. So the steel should be green steel. I mean, there are steel companies. They are also now making it. It doesn't mean that it looks green, but it is basically from the green sources, and from energy point of view, as well as using the green hydrogen, for example. So green steel. So the green steel being used to be used in transformers. Similarly, so all material and different type of aspects of the asset themselves, they have to be sustainable. So produce green, consume green. So not just EV having consuming the fossil fuel energy, but EV also sort of consuming using the renewable energy. And in the value chain, again, having the sustainable products like Econic I talked about, and so transmit green. That's what I say.
That's very insightful, Akilji. Thank you. Pankaj, can we have your inputs? My question was, how are we going to address the challenges to achieve sustainable energy transition?
Mr. Akhil also said, the transition process is happening multifold. It is happening from industries to transport to various other aspects of our daily lives and our future growth. But my point is that, this is all happening to meet the demand. Unless we parallelly work to reduce our consumption in all fields, because today we are transitioning from fossil to electrical, and probably in 10 years down the line, we may be having some other issues and we will be having energy transition to some other sources. So those things will always continue as we move along. But is the consumption is something which is in the human control. And even if we are a very spiritually conscious country, in a spiritually conscious country, consumption control is prime important. So my thing is that the process of transition of technologies, fuels will continue happening, and we have to continue striving to develop economy. But at the same time, there has to be a due focus on reducing consumption in every field. And the consumption will drive to lower generation, will have less effect on environment. So this will have multi advantages as well. This is my point.
Thank you, Pankaj, for answering that. Rajeshji, can you share your inputs?
And I have already expressed in the beginning of my presentation that in power sector, transmission, distribution, there are three main areas. It is procurement, commissioning, testings, and maintenance, condition monitoring of equipments. When I say procurement of material, suppose I am buying some gas insulated substation, and that is using SF6, as very well narrated by my previous panelist. If we are not changing from SF6 that is penetrating into my atmosphere, creating problems with some green gases produced by many OEM in India, they are offering it. It is of no use. At the same time, the transformer, we are using transformer and all the materials who are producing, who the basically making small components of that transformers are not using green energy, you can't think of sustainable development in India. We have to take very first step. We have to take first step in the 1,000 miles of journey, and with the support and efforts of everyone, we will be able to achieve that sustainable development in my transmission and distribution sector one day. I'm quite sure about it. We have to support government. We have to take step. We have to take action at our end. We have to change our specification. We have to adopt new technologies available. That is possible.
Absolutely agree with you. The question is, what is the role of BEE in improving energy efficiency? We have this question in the Q&A box from Jay Prakash Chaubey.
BE is Bureau of Energy Efficiency is a part of Ministry of Power in India. And the role of Bureau of Energy Efficiency is to reduce energy consumption of building, or these mandates like energy efficiency, energy conservation building codes. All these are launched by BEE. The BEE role is also the rating system of air conditioners and appliances. And all these, when they say the rating, like 5-star rating, 4-star, 3-star, and all these rating systems, the role of BE is to continuously upgrade those bar or the levels, so that energy consumption as a whole is reduced. Like for example, a 5-star versus 3-star has approximately 10 to 15% more energy efficient. So this is the role of from the policy side of Ministry of Power, and for ensuring that it is implemented. That's how the BE gets accreditations to buildings. And at the same time, it is also skilling the manpower in India. He is giving energy managers, energy auditors. These are skilled manpower to audit buildings and certify the buildings that they are energy efficient.
Thank you for answering that. Saloni, would you like to add in?
Mr. Gupta covered everything. Just one point I would like to add is the Bureau of Energy Efficiency very recently also came up with the CCTS, which is the carbon credit trading scheme, which has been an extension to the PAT, which is the Perform, Achieve and Trade scheme, where the idea has been that the industries come together in measuring the carbon emission and calculating the cost of this emission. So I think that is another key role that we plays is now in developing the India's domestic carbon market after the failure of the CDA mechanism or the PAT not taking off as it was expected. So I think that is just one very quick point that I would like to add.
Thank you so much for sharing your expertise. Moving ahead, I would like to have the closing statement from Akhil Urji.
When we talk about energy transition, so it's not a destination, it's a journey, as we know that it has already started, especially for a step change, 2030 target, 2070. And in this, several decades, I think the technology will change. Different type of business model will also emerge. I think what's very important is the collaboration among all the stakeholders, much more than ever, because this is how we can implement the technology, monetize the technology implementation in the energy transition, and make it sustainable.
Thank you, sir.